Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to continue my video series on trigonometry, so if you find this video helpful, consider hitting the like button and subscribing, and let's go. Now, today I want to talk about the Pythagorean identities. These are likely the first identities after your quotient and reciprocal identities in trigonometry that you will learn. So, quotient and reciprocal, that's just really SOHCAHTOA in a fancy way. Pythagorean identities, we're going to see it's similar. Now, as the name suggests, these tie back to the Pythagorean Theorem, but a lot of students don't know why they tie back to the Pythagorean Theorem and why they're called Pythagorean identities. And I'm going to show you right now why this is the case. And it all starts with a right triangle, and in particular, we can think of a right triangle living in our plane on the unit circle. So here's a circle and here is a triangle in it. And it doesn't matter that I'm drawing this triangle in the first quadrant. You can similarly draw triangles in any quadrant you want. This same idea is what's going to hold. Now, if I'm interested in this point here on my unit circle, I can think of the coordinates as it being x and y. So I can think of those points as being x and y. And I can also think of this angle here being an angle called theta. So I've set up a right triangle, and I have it this way. Now, my leg here is my x leg, and my leg that goes vertically up is my y leg, so I'll label that, and I know my hypotenuse is 1 in this picture if I'm living on the unit circle. So here's the two key pieces of information I have. The Pythagorean Theorem tells me that x squared plus y squared is equal to 1 squared. So the sum of the squares of my legs in my right triangle are equal to the square of the hypotenuse. And since it's 1 here, hypotenuse, I can just make that be a 1. So here's my what the Pythagorean Theorem tells us. My right triangle trig tells me when I look at SOHCAHTOA, sine of theta is opposite over hypotenuse. So the y leg divided by 1. And cosine of theta is going to be the adjacent leg divided by the hypotenuse. So x divided by 1. Well, any number divided by 1 is just itself. So sine of theta is really just y. And cosine of theta is really just x. Well, here's where I take my information from the Pythagorean Theorem and my right triangle trig and combine them. If y is equal to sine of theta, I can replace y in my Pythagorean Theorem equation by sine of theta. And similarly, since cosine of theta is equal to x, I can take x in my Pythagorean Theorem equation and replace that with cosine of theta to give me cosine theta all squared plus sine theta all squared equals to 1. And since its addition is commutative and the way we denote our squareds is by moving our powers inside by the letters. This is the same thing as sine squared of theta plus cosine squared theta is equal to 1. This is the very first Pythagorean identity. Sine squared of theta plus cosine squared theta is equal to 1. Now I wrote x in my little document here, but that doesn't matter. That's just a variable. It's whatever letter you want. This will always hold. This is the most basic Pythagorean identity and the one that most people are going to remember. So here we can clearly see how it comes from the Pythagorean Theorem. The question is, where do the other two come from? And this approach that I'm going to show you now isn't a formal proof because I'm working across the equal sign, but this will give you an idea of where they come from. Because I know I always forget what the other two are. So if I want to look at them, I'm going to start with this Pythagorean identity we just actually proved. So let's start trying to find tangent squared x plus 1 is equal to secant squared x. So for that, we're going to start with the Pythagorean identity we just proved. And in this, the difference between sine squared and tangent squared is a cosine squared. And you'll notice if I divide everything on the left by cosine squared of x, and I divide everything on the right here by cosine squared of x, I'll have the following, which when I try to simplify it, sine squared over cosine squared by a quotient identity is just tangent squared. Cosine squared divided by cosine squared is going to be 1. And 1 divided by cosine squared by a reciprocal identity is just secant squared. Well, that's the second Pythagorean identity. So to find our next Pythagorean identity, just take the one we proved, sine squared x plus cosine squared x is equal to 1, and divide everything by cosine squared of x, and you'll get our next identity. For the last identity, we will do the same thing, but instead of dividing by cosine squared of x, we will divide by sine squared of x. And when I do this, I get the following, which gives me 1, because sine squared divided by sine squared will be 1, plus cosine squared divided by sine squared, which is just cotangent squared by the quotient identities, is equal to 1 over sine squared, which is really cosecant squared of x by our reciprocal identities. So we end up with our third Pythagorean identity. So what this tells us is all of these identities relate back to the triangle, our right triangle in the Pythagorean theorem. If you know sine squared of x plus cosine squared x is equal to 1, or theta, whatever you want to call it, what you're plugging inside, if you know that identity, you can always quickly recreate the other two by dividing both sides by either cosine squared or dividing both sides by sine squared. That will let you recover the other two if you forget. So here's our Pythagorean identities, 3 of the most important early on identities you're going to learn in pre-calculus. I hope you found this video helpful. If you did, hit the like button and have an awesome day.